Let's look at the limit theorems. Now I copied this from a document that I linked to in the description of this video. Here you have 7 results which we're going to look at. Now remember, it says since all limits are taken as n tend to infinity, so everything else here n is tending towards infinity. In the theorems below we will write lim an for lim n tend to infinity of an. Alright, so they're leaving off the n tend to infinity, but everything means that I guess they didn't want to crowd the writing too much by keeping or continually writing n to tend to infinity all the time. Alright, now it says let an and bn be 2 sequences such that an tend towards a number n and bn tend towards a number b. Alright, an tends to a and bn tends to b. With a and b real numbers, then the following results hold. Alright, so let's see what the first result says. The limit of an plus or minus bn is equal to the limit of an plus or minus the limit of bn, which is equal to a plus b. Let's look at an example of this and see what they're saying. Well, first of all, remember that if you have the limit as x tends to infinity of a number plus 1 over x is just equal to that number. The number is not affected, right? For example, suppose the number was 30. The result would be 30. If x multiplies 30 now, or x divides 30 or something like that, then you'd have a different case. But 30 is a constant here, and it wasn't divided or multiplied by x. X keeps changing, but the 30 remains. Alright, let's look at an example of the first one. Let me see now. Suppose the sequence an is, let's say, 7 plus 1 over n. And let's see, this is the one we're looking at now. Let's say bn is a sequence 3 plus half raised to the power of n. Alright. Now, what's the limit as n tends to infinity? What's the limit of an? We see here that 7 plus 1 over n becomes 7 plus 1 over, as n tend to infinity, 1 over n tend to 0, so it's 7 plus 0. You see that? Because the first term would be 7 plus 1 over 1. Second term would be 7 plus 1 over 2. Third term is 7 plus 1 over 3. The 100th term would be 7 plus 1 over 100. Very small. The 1000th term would be 7 plus 1 over 1000. 1 over 1000 is so small, it hardly changes anything. So as we go on and on, this part becomes less significant. So the limit becomes 7. So the limit of an is 7. Alright? Let's see the limit of bn. This is bn. I said that bn was 3 plus half to the n. Alright. Let me erase this and rewrite it in another color. So bn is equal to 3 plus half to the power of n. Now, here, as n tends to infinity, bn would equal to 3 plus, well, what is half raised to the power of a large number. I know that half raised to the power of 5 would be 1 over 32. It's small. Half raised to the power of 10 would be 1 over 1024, which is even smaller. So as we go on, this part becomes smaller and smaller. So Bn would tend to 3. So the limit as n tends to infinity of Bn is equal to 3. Now, the limit of An plus the limit of Bn. The limit of An is 7 plus the limit of Bn would be 3. So the answer here would be 10. Let's see something. If we say the limit of An minus the limit of Bn, we would have 7 minus 3, which would be 4. If we minus, that's what would happen. If we plus, this is what would happen. Now, we found the limit of An alone, which is 7, and found the limit of Bn alone, which is 3. Suppose we try, and then we found that 7 plus 3 is 10, and 7 minus 3 is 4. Suppose we put them together, as in this case. What would happen? If we put everything together, An plus Bn. An plus Bn would be what? Let me rewrite it. So, An plus Bn is equal to, it would be 7 plus 1 over n plus, about Bn now. It would be 3 plus half to the power of n equals. Now 7, you have the 7 plus 3, could put that together. We have 7 plus 3 plus, and we have 1 over n plus half to the power of n. Alright, so this becomes, let me partition here, this becomes 10. 7 and 3 is 10 plus 1 over n plus 1 over 2 to the n. Alright, what happens as n tends to infinity? As n tends to infinity, the 10 remains. And then 1 over n would tend to 0, and half to the n would tend to 0. Because you see, the first term would be 10 plus 1 over 1 plus half to the power of 1, which is half. The second term would be 10 plus 1 over 2 plus half squared, which is a quarter. The third term would be 10 plus 1 over 3 plus half raised to the power of 3, which is 1/8. The thousandth term, which will be 10 plus 1 over 1,000 plus 1 over 1024. And this is very, very small. This is very, very small. And they keep getting smaller and smaller, and the 10 remains. So this tends to 0, and this tends to 0, and the 10 remains. So this is 0 plus 0. So if we put both of them together, as in this case, and add them, we get 0. I mean, we get 10. We get 10, just as in this case. It does seem to work for the addition. Let's try the subtraction. Suppose we put them together and subtract. What would happen? Would we also get 4? Let's see. Remember, this is saying plus or minus. So an plus or minus bn. So we haven't done the minus part for this. So let's do the minus part. Minus bn equals an is 7 plus 1 over n minus, let's put them in bracket, bn is 3 plus half to the power of n. Let's see what happens here. 7 plus 1 over n minus 3 minus half to the n. Now, if we put things together, the numbers together, 7 minus 3, and the n's together, plus 1 over n minus half to the n. Here, 7 minus 3 is 4. Plus, what would happen? Here, this is 4 plus 1 over n minus a half to the n. The first term would be 4 plus 1 over 1 minus half to the power of 1. And so on. The thousandth term would be 4 plus 1 over 1,000 plus half raised to the power of 1,000, which is 1 over 1,024. And this would be very, very small. This would be very, very small. So adding these two would be very, very small. So the 4 would remain. Right, so we've seen an example of this one. All right, it does work out. If you find the limit of the sum of the two functions, it's the same thing as saying the limit of one function plus the limit of the other function. So it does work. Let's look at the second result in a different video. We've looked at the first result, an example of the first result here, as we look at limit theorem. Let's look at the second result. Suppose an is equal to 7 plus 1 over n, and suppose bn is equal to 3 plus 1 over 2 to the power of n. Same thing as half to the power of n. Alright, now if you multiply, let us multiply the two of them and see what happens. We have an bn is equal to, it's going to be 7 plus 1 over n multiplied by 3 plus 1 over 2 to the n. Alright, now what happens? 7 times 3 is 21, plus 7 times this is 7 over 2 to the n, plus n, 1 over n times 3 is 3 over n, plus 1 over n times 1 over 2 to the n is 1 divided by n, 2 to the n. Now, let n tend to infinity. You have 21 plus 7 over, well, as this n becomes larger and larger, you know that 2 square is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. This is becoming larger and larger, infinitely large. Plus 3 divided by, as n tends to infinity, this becomes infinitely large as well. This is tending to 0, this is tending to 0. Alright, plus 1 over this here is tending to a very large number, times, and this is tending to a very large number. So this is 1 over a large number, this is tending to 0. This is 21. So the result would be 21 here. Now, let's do them independently and multiply and see if we get back the 21. So let's erase these to make space. I don't want to touch the 21 there. Alright, we have an, where an is 7 plus 1 over n. Now, the limit as n tend to infinity of 7 plus 1 over n equals, we know that as n becomes bigger and bigger and bigger, this part will tend, n will tend to infinity. Well, let me write it up here. So you have 7 plus 1 over a very large number. This part would tend to 0. So it's 7. Alright. What would happen to Bn? Here, the limit as n tends to infinity of 3 plus 1 over 2 to the n equals, oh, by the way, our bracket would be around these. I don't want it to look as if I'm just finding the limit of 7 alone. So let me put the bracket around them so that the limit applies to both of them. Alright, here, this is 3 plus, when you have 1 over 2 to the n, and n tends to infinity, the 2 to the n would become bigger and bigger and bigger, and the 1 over that would become smaller and smaller and smaller. So this would tend to 0. All of this part would tend to 0. So it's 3 plus 0 equals 3. Now let's multiply them. 3 by 7. 3 multiplied by 7 equals 21. So we have multiplied both functions and found the limit. And when we found the limit of one function, found the limit of the other function and multiply them, and we got the same answer. So if we multiply the limits, 3 by 7, we get 21, which in this case would be AB. Alright? So that's the second result, an example of the second result.